Good day, listeners, and welcome to our first program in a series of 5 on physics for grade 10 and 11. My name is Audrey Polton. Please have a pen and notebook ready and listen carefully. In this program, we are going to explain the production and properties of sound. Let's join Alice and her mum.
Will you turn down the volume, please, Alice? I can't hear myself think.
Oh, Mom, this is not loud. You can't be serious. Wait till you hear what they do in the club. You're in for a surprise, Mom.
Alice, what are you saying? When have you been in a club? I thought I could trust you, my own daughter, to be truthful and honest with your father and me.
Mom, stop. Wait a minute. I never said I went there. I just said you must hear what they do there.
Okay, I hear you, but I don't understand what you're trying to say. Let's start over. How do you know what happens there if you've never been there?
Oh, Mom, I have friends, and they go places. They tell me things, and that's how I know. I'm honest with you when I say that I don't want to visit those places. It's not for me.
Thank goodness. I'm glad to hear that. And thank you for being who you are. So tell your old ma what happens there.
It's nothing really. Just the sound is so loud that people can't talk to each other. If they want to talk, they must scream to be heard. It's obviously things we know about, but to be surrounded with loud and sometimes bad music like that is too much for me. I keep asking my friends how do they do it and why do they keep going back? Apparently they like it, but I have my doubts about that. It feels more as if you must be forced into going there instead of choosing for yourself to be there. Apart from the unpleasantness of the noise, it can damage your hearing. I wonder how it's that they don't have a law that can limit noise levels, even in clubs. Imagine they expect people to wear protection like ear mufflers to prevent their hearing from being damaged. Haha.
Do you know why it can hurt your ears? It's because of the high amplitude that these loud sound waves have. They have lots of energy, which can hurt or even damage your ears. It's definitely worth it to protect your ears against loud noise. In the end, you're the one with the problem if you've neglected to take care in your younger days.
I was just thinking now about how interesting sound actually is. It's just a matter of particles vibrating, creating a lot of energy and causing waves. Did you know, Mom, that sound travels fastest through solids? And they travel slowly through liquids and even more slowly through air. But it's also interesting that it cannot travel through a vacuum. Sound also travels faster in warm air and travels faster in still than in glass, because glass is actually liquid. How cool is that?
Now that you mention that, I'm reminded of the times we spent on the farm when we were children, wandering around in the field, and we would be shouting like crazy. We always marveled at the echoes that came back after some time. It always worked better when there were more mountains around us. Isn't it interesting that science is such an integral part of our lives, even when we don't realize or understand it? These days we enjoy the phenomenon of echoes, which we can explain scientifically. Obviously, the boys and girls used to shout to compete against each other. We loved to hear the difference in pitch. We never even knew anything about frequency, vibration, or pitch. We just enjoyed ourselves. Now I know that a high frequency produces a sound with a high pitch, and frequency is the number of waves that pass a point every second. That brings me to the noise in our house. When will you turn it down?
Oopsie. I enjoyed our talk so much. I forgot that you had a problem with the amplitude of my music. I understand why you say it's loud. It does sound very loud to me now. I suppose we can also cause noise pollution, like aircraft, motor vehicles, and many other types of machineries. It's good that we don't hear sounds of frequency that some animals can hear, or even ultrasound. That is beyond the range of human hearing.
Well, listeners, there you have it. Sound and noise pollution. Interesting, isn't it? When we talk about sound, we mean particles that vibrate and make the air vibrate. Sound waves travel through gases, liquids, and solids. The medium through which they travel best is solids. Sound waves cannot travel through a vacuum. The human ear hears sounds between about 20 Hz and 20,000 Hz. Sounds that are higher than 20,000 Hz are outside our range of hearing and are called ultrasonic or supersonic. Your ears are most sensitive to frequencies of about 2,000 Hz. Sound waves travel much more slowly than light waves. Let's have a look at how the ear hears sounds. When you hit a drum, the sound energy spreads out in all directions. Only a small amount of the total sound energy from the drum will reach your ears. Thus, sound energy causes a thin membrane in the ear called the eardrum to vibrate. This membrane vibrates at the same frequency as the drum you hit. If the drum vibrates at 40 Hz, the membrane in your ear will also vibrate at 40 Hz. The vibrations of the eardrum are transferred to nerve messages in your ears. These nerve messages are sent to the brain. These messages tell the brain whether the sound waves have a large or small amplitude or whether the sound waves have a large or small amplitude or how loud they are, and whether the sound has a high pitch or a low pitch of frequency. A very important thing to remember is that if you regularly listen to very loud music, or if you're constantly surrounded by loud noise, it can hurt your ears because loud sound waves have a high amplitude. They have lots of energy which can hurt or even damage your ears. Reflected sound waves are called echoes. Echoes are sound waves reflected off surfaces, which means that it becomes difficult to get an echo if you do not have objects reflecting the sound back to you. In our next program, we'll talk about another topic of physics. So please keep listening to our educational radio programs. Until then, from me, Audrey Polton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Good day, listeners. My name is Audrey Polton. Welcome to our second educational program in a series of 5 for grade 10 and 11 physics learners. I'm sure these educational programs will help you to understand more of the difficult content of this subject. So listen carefully, but also enjoy. During this program, we're going to listen to a conversation about radioactive elements between two friends, Edwina and Ndapewa.
Hi, Ndapewa. Welcome. Come in, my friend.
Hi, Edwina. Thanks for inviting me. I'm curious to know why you asked me over in the middle of the week.
Please, let's go through to the sitting room.
Okay, I'll take the couch. You have one of the chairs.
Well, it's rather complicated, but let me start at the beginning. A few weeks ago, I applied for a holiday job at Rosing Uranium Mine. Yesterday, they phoned to inform me that I'm on the shortlist for the job, but I have to go in for an interview.
Oh, but that's good news. Or isn't it?
Yes, it is, but I have to find out more about radioactive elements since uranium is one. I want to impress them to get the job, so please explain the meaning of radioactivity to me.
All right. Can you remember we learned in school that the nucleus of an element contains particles called protons and neutrons?
Yes, I do. I remember the protons have a positive charge and neutrons have no charge.
That's right. Atoms with few protons and neutrons in the nucleus tend to be stable, but atoms of some elements such as uranium, polonium, and radium have far more neutrons than they have protons in their nuclei.
I remember atoms of an element with different numbers of neutrons are called isotopes of that element.
Correct. And due to the large number of neutrons present in their nuclei, they are unstable atoms. So, in order for them to become stable again, they lose some of the energy in their nuclei.
Wow, okay, but how do these isotopes lose energy?
Isotopes send out some of the particles in their nuclei. This is called radiation.
Radiation? Oh, so what you're saying is when an atom is emitting some of its particles, it's losing energy and it becomes stable.
That's right. The atom emits 3 types of radiation, namely alpha, beta, and gamma.
Strange names for radiation. Alpha, beta, and gamma.
They're named after the first 3 letters of the Greek alphabet, Edwina. Do you know some uses of uranium?
Yes, I do. Namibia exports these radioactive elements to other countries to generate electricity in nuclear power stations. Another use of uranium for nuclear weapons.
Good. Now you're ready for your job interview with the mine, and I'm sure you'll be successful, Edwina.
Thank you so much for your time and knowledge you shared with me, my friend.
Isn't it good to know that our country has a mine rich in a radioactive element such as uranium? Now let's quickly summarize the main points of today's program. Uranium, polonium, and radium are but a few examples of radioactive elements. The atoms of these elements have large numbers of neutrons in their nuclei, which make them unstable. In order to become stable again, they lose some of the particles from the nuclei. This is called radiation. There are 3 types of radiation, namely alpha, beta, and gamma, named after the first 3 letters of the Greek alphabet. Radioactive elements can be very useful, but it can be extremely harmful as well. Uranium is used to produce electricity in nuclear power stations and for nuclear weapons. With this, we come to the end of our program for today. Thanks for joining us today. From me, Audrey Polton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Hello listeners, my name is Audrey Polton and I welcome you to our third educational program in a series of 5 for grade 10 and 11 physics learners. Other listeners who are not currently studying this course, please enjoy the program with us. During today's program, we're going to find out more about forces. Edwina and one of her friends, Ndapewa, are on their way to a grocery shop where they discover how many forces are at work inside the shop.
Hey Ndapewa, how are you?
Hey, I'm fine. Thanks, Edwina. Looks like you're in a hurry. Where are you going?
I'm on my way to buy groceries for my mom. Join me. It's so boring to buy groceries alone.
Yeah, sure. Why not? I don't have anything else to do. I can push the trolley for you.
Would you mind to get us a big shop trolley while I try to find my mom's shopping list in my handbag?
Sure, no problem.
Ndapewa, just make sure the walls of the trolley are in good working condition. Because if they don't turn freely, the friction is going to become a problem when the trolley is filled.
Friction? What friction?
You know, the force acting against the movement of the trolley. When you push the trolley forward and the wheels don't turn freely, friction appears between the wheels and the floor. It will slow the trolley down and you'll have to use more effort to push it.
Ah, okay. I found a new plastic one. It doesn't have much weight.
What do you mean?
Well, it's easy to push around. I estimate the mass of the plastic trolley to be about 10 kilograms. The weight of the trolley will then be 100 newtons.
Gee, how do you work that one out?
The force of gravity on the trolley is called weight. The value of the Earth's gravity on the trolley is 10 newton per kilogram. Multiply the trolley's mass with the Earth's gravity and you come up with 100 newton.
10 kilograms multiplied by 10 newton per kilogram equals 100 newton. Oh yes, but let's hurry. I don't have to be in the shop forever.
Oh man, it's becoming very hard to get the trolley going when it's been standing still. Is it because of the extra mass of the groceries?
For sure, yes. An object at rest tends to stay at rest, and if the trolley moves, you have difficulties to control it because it tends to carry on moving.
Yes, that is so. But why?
This is called inertia. The mass of the trolley loaded with groceries is a measure of its inertia. If the trolley of groceries has a high mass, it will have a high inertia. Therefore, you'll have trouble getting it to move or to control it when it's moving.
The trolley is filled already. How much more is on that grocery list?
Oh, I'm done. And just in time, let's move to the pay point because I need to get out of here. Okay, I see a vacant pay point. Over there, to the right.
You know, Edwina, turning this trolley to the right makes me realize that forces are always applied in a certain direction. Throughout our shopping spree, I was pushing the trolley towards the shelves with the needed items on, and now I'm steering it in the direction of a vacant pay point.
You're right. A force is a push or a pull exerted on an object, which makes the object move in a certain direction.
So one can say that all forces have size or magnitude and direction. This makes forces an example of a vector quantity.
Yes, correct. Hey, girlfriend. Thanks for being here with me and helping me with the boring task. Let's unpack the trolley now. And afterwards, I'll seek you for an ice cream at Wimpy.
Do you agree that forces are all around us? There where you are now, you are also surrounded by various kinds of forces. Let's quickly summarize before we get to the end. A force is a push or a pull on an object in a certain direction. A force has size and direction and is therefore classified as a vector quantity. The unit in which force is measured is called Newton. All objects have mass. To work out the gravitational force of the Earth on an object, multiply the mass of the object with 10 Newton per kilogram. This force is said to be the weight of the object. Friction is also acting on objects. This force acts against the movement of an object. When friction is high, one needs more force or effort to move an object. When an object is at rest, it tends to stay at rest until a force acts upon it, or while moving, it tends to carry on moving until a force acts upon it and makes it stop or change direction. This phenomenon is called inertia. With that, we've reached the end of our program for today. Thanks for joining us. Stay tuned into our educational radio programs. From me, Audrey Polton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Hello listeners, my name is Audrey Polton. Welcome to our 4th educational program in a series of 5 for grade 10 and 11 physics learners. Other learners who are not currently studying this course, please enjoy the program with us. Today we'll focus on eyesight defects and how to correct them. Let's listen.
I wonder what's wrong with my eyes. I can't see properly on the blackboard anymore.
Hey Edwina, that's what happens when one goes out drinking. Alcohol affects your brain, you know.
Come on, Dapewa. You know I don't drink. I've been experiencing it for quite some time now. Maybe I should talk to our teacher and ask him if he can move me to the front of the class.
It sounds to me that you're short-sighted, Edwina. You can see objects that are close by clearly, but far away objects appear blurry.
Yes, I think you're right. Do you mind going with me to see Miss Polton? I think she needs to know about this.
Sure. It's the break and we have time now to inform her. Miss, sorry for bothering you, but I have a request.
Yes, Ntapewa, how can I help?
Edwina is short-sighted and has trouble seeing the blackboard from where we sit at the back of the classroom.
Miss, is it possible for me to move to the front from tomorrow onwards?
No problem, I'll do so. But Edwina, you need to see an optometrist. Short-sightedness can be corrected by wearing a certain type of lens.
Oh, so I need to get spectacles?
Yes, ask your mother to make an appointment for you at an optometrist. Your eye lenses are too powerful and they focus the light rays from distant objects in front of the retina. This is why you cannot focus on distant objects such as the blackboard.
Miss, how will an optometrist correct it?
He'll give you spectacles with diverging lenses. This type of lens spread light rays out. The eye lens will bring them into focus on the retina again.
That sounds wonderful. Then I can remain seated at the back of the class with Napewa.
Yes, when you have your spectacles. Until then, you need to join me in front of the classroom.
Thank you, Miss.
Thank you, Miss.
You're welcome.
My grandpa is far-sighted. It's just the opposite of short-sightedness.
What do you mean the opposite?
He can't focus on objects close to his eyes, but he can see distant objects quite clearly.
So, he should sit at the back of the class and not in front.
You can say that, but his eye lenses are too weak and focus the light rays from close-by objects behind the retina. That's why my grandpa cannot focus on objects directly in front of him.
What kind of spectacles does he wear?
ones with converging lenses. It helps him to bend light rays inwards to focus on the retina again. He needs his glasses to read a book, but he doesn't need them to watch television. It sounds strange, but it's true.
I'm so excited now. Can't wait to get home this afternoon to ask my mom to make an appointment. I'm so excited now. Can't wait to get home this afternoon to ask my mom to make an appointment for me at an optometrist.
What an interesting conversation. Let's quickly summarize. Side effects develop in the human eye when the lenses become too powerful or too weak to bend light rays to focus on the retina. Powerful eye lenses lead to short sight because they focus the rays in the front of the retina of the eye. You can also say short of the retina. Distant objects appear blurry. To correct this, spectacles with diverging lenses are needed. This defect happens mostly in young people's eyes. Weak eye lenses lead to long sight. Light rays are focused behind the retina of the eye. Close by objects appear blurry. To correct this, spectacles with converging lenses can be worn. This defect happens in older people's eyes who will then need glasses for reading. This concludes the 4th program in this series. Thanks for following our series on physical science. From me, Audrey Polton, happy studying and goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Good day, listeners, and welcome to our last program in a series of 5 on physics for grade 10 and 11. My name is Audrey Polton. Please have a pen and a notebook ready and listen carefully. In this program, we're going to discuss mass and weight.
Hi Alice, how are you doing today?
I'm just fine, girl. Just trying to get rid of this weight around my body. I'm sick and tired of being called fat.
Oh Alice, I understand your frustration. Sometimes people can be so hard on others with all their comments. If they could only realize how much damage they do to a person's self-image with all their negative remarks.
I agree with you. The doctor suggested that I must lose some weight to control my blood pressure. You know, since last exam, I suddenly developed high blood pressure during the exams. I can't believe it. I'm still young and energetic.
Yeah, you must remember that here in Namibia, we eat too much meat.
I know, and on top of that, I'm struggling with physical science. I have to write a test next week. You must come over to our house during the week, and then I can try out that nice pizza recipe of my mom's while you explain to me some of the concepts in physics.
Pizza of all things. I thought you were watching your diet, girl.
Just one slice, my friend. I'm trying my best to follow the dietitian's diet plan. I may spoil myself once a week. I'm working very hard. Come on. I'll be waiting for you on Friday afternoon, please.
Okay, no problem, my dear friend. I'll see you around 4 o'clock on Friday afternoon. Bye for now. Have a nice day.
Ciao, my friend. Let me tackle the treadmill over there. Ah, that must be Jane. Can't wait to see her. Come in.
Hi, girl. How are you today? It smells good in here. Is that the homemade pizza? Can't wait to have a taste.
Yes, me too. And guess what? I've lost 2 kilograms of weight this month. Something to celebrate, my dear.
Well, hang on. Before we celebrate, let's get the serious business out of the way. What did you want me to explain to you concerning physics?
Oh yes, it's the stuff about mass and weight. Do mass and weight mean the same thing?
Well, you know how you said just now that you have lost 2 kilograms of weight this month?
Yes. What's wrong with that? I meant that I've lost some weight.
That's good. But do you know that you have actually lost mass and not weight? There's a difference between the two terms. Mass is the amount of matter that an object has, whilst weight is the gravitation force of Earth on an object.
Oh. Okay then. I've lost 2 kilograms of body mass, which is mostly fat. So what you're saying is that mass is measured in kilograms, but then how does one measure weight?
Weight is measured in Newton since it's a force.
Wow. Can you believe it? Finally, mass and weight is starting to make sense to me. But Miss Devere told us this morning that you can actually calculate weight from a person's body mass. I don't get that.
Well, it's true. You can calculate your weight from your amount of mass. The formula we use is weight equals mass multiplied by the gravitational acceleration. We always use a gravitational acceleration of 10 meters per second squared in calculation.
Oh, interesting. So, the 2 kilograms of mass I've lost is how much weight?
As I told you already, weight is mass times the gravitational acceleration of 10 meters per second squared. So, it's 2 multiplied by 10, and that gives us 20 Newton. Remember, weight is measured in Newton.
Now we can rewrite our formula so that we can calculate mass from the amount of weight.
Yes, mass is the weight divided by the gravitational acceleration of 10 meters per second squared.
Ah, now I've got it. If an object has a weight of 800 Newton, its mass is 800 divided by 10, and it gives us 80 kilograms.
Clever girl. Is there anything else you don't understand?
Yes, I've heard about the concept of inertia, but I don't have a clue what it is.
Okay, inertia is the resistance of changes in motion of a mass. For example, if the driver of a car suddenly brakes, the passenger's body tends to move forward. And that's what we call inertia. The more mass an object has, the more inertia it has.
You really are the best, my friend. I don't know what I would do without you. I feel much better about that science test now.
No problem. I think it's about time to get some of that pizza. Yummy.
Yes, let's have some pizza.
Listeners, there you have it all. What a mouthful about mass and weight. I hope you'll now understand the concepts of mass, weight and inertia. How about us going over it again one more time? Well, mass is a measurement of how much matter is in an object. Weight is a measurement of how hard gravity is pulling on that object. Your mass is the same wherever you are. On Earth, on the moon, floating in space, because the amount of stuff you're made of doesn't change. But your weight depends on how much gravity is acting on you at that moment. You weigh less on the moon than on Earth. And in interstellar space, you'd weigh almost nothing at all. The symbol for mass is m and is measured in kilograms. The weight of an object is a product of its mass times the acceleration of gravity. The symbol for weight is W and is measured in Newton. So the weight of a 30 kilogram mass is 30 times 10, which is 300 Newton. And so we can calculate mass from the weight of an object. Mass is the weight divided by 10. The most difficult part is understanding the difference between weight and mass, as people tend to use the words weight and mass interchangeable. They use kilograms for weight when they should use Newton. Even your doctor may discuss your weight when he meant to discuss your mass. All objects have inertia. The more massive they are, the more inertia they have. Inertia is the reluctance of an object to change the way it is moving. If it's still, it stays still. And if it's moving, it keeps on moving in the same way unless a force acts on it. We have come to the end of our physics programs. From me, Audrey Polton, goodbye.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.